Thank you. Today we're going to explore modern data platform using an human body analogy. I believe every engineer struggles explaining what exactly we do in our job, like for stakeholders, end users, for Vive, even kids. So I love analogies actually. And I promise in the end of this talk, you will have another great analogy to explain your education, maybe your job. Despite of interests of human body, I'm a software engineer since 2008 and building data platforms since 2014. At that time, we were building data platforms using relational databases like MySQL, PostgreSQL. It was painful what we did. Luckily, then Hadoop and Spark, Yarn appeared, and I was programming in Scala for the next, I believe, 5 years, until fully ready to use platforms introduced. For the next 3 years, I'm a vibe coding data platforms on GCP, AWS, and Databricks. At this moment, fintech company Salman. Few words about Salman, a technology-driven financial company building a banking and lending platform in South Asia. By the way, there is a fact about Philippines. It's area of Philippines around 300 square kilometers. It's a bit less than Finland, but population here around 220 million, I would say. So and keep growing as a finance market, which is doubled for the last decade. And to here we operate at this moment. So inside of the Salman Group, we have a bank, as I mentioned. It's a finance organization. We have lending platform, POS, credit lines, revolving credit lines. And basically, we work with money, real clients' money. And, I was surprised. The market in Philippines is quite mature. There is a quite tight regulation. There are many well-funded players, and at the basic fintech challenges, right? Almost your efforts impact on clients' money, especially while you're working with data, with production data. Moreover, company is doing great, and we grow more than 2 times for the last year. So for data teams, it means user growth, more analysis, scientists, ops people, all want data yesterday, volume grows, more sources, more history, more tables, and pipelines. Every answer becomes a pipeline, every pipeline becomes a dependency. And the team, data team, we stay same size, 4 engineers actually. And how we would address all these challenges, how we solve all these challenges. Basically, we just bought Databricks, guys. That's all. Thanks for coming. Any questions? Obviously, it doesn't work like that, right? At that moment, we think that to just buy some expensive tool and resolve all these challenges. But unfortunately, we did a lot of mistakes with Databricks, actually. A great tool is not a strategy, and moreover, in wrong hands, a great tool, even expensive tool, just produce much more problems. And we did a lot of them, like we just let data users, use Databricks as they wish, and they, produce non-versioned pipelines, no history, no deployment, no test. Lack of security, no ownership. Nobody knows who owns data or pipelines, right? No code standards. So luckily, we reconsider our approach early enough and start to cure all this problem. And there is an interesting, wise Chinese proverb, all illnesses enter through the mouth, right? So we're considering what we consume as a data, right? So basically, 80% of our data sources are RDS databases. And we ingest them using AWS DMS. DMS means data management system. And you can picture it like data packing system, right? Food packing system. And it's, just grab all these variety tables and pack into two ways, like CDC, change data capture, right? And snapshot. And by the way, there is a lack of efficiency, especially for batch processes, right? For snapshots. Let's say we need data once a day only, right? In this case, rest of the time, our system and our food packing system just running without any load and just consuming electricity. So to address it, we have a parallel watchdog system which downscales and upscales our system. It depends on there are food to consume or not. So it is pretty good for batch, not CDC. And it helps us to reduce into 40% our costs in AWS. It's a bottom line here. Manage doesn't mean optimize. The cloud always, happily build for idle processes as well. Okay, cool. We consume wide variety of food. Let's say, how are we going to extract energy, nutrients, vitamins from all this? And here, dbt is rolling in. I believe one of the most important part of any data platform at this moment. Please raise your hands who familiar with dbt. Cool. Okay. Nice. So basically, dbt is like a framework, SQL framework, even template. If there are some complex data processing or transformation, I would recommend it. In our case, dbt allows us to filter garbage from data, like food. Some data can be low quality or even outdated. What if food producers promise you that there is no sugar, right? And eventually there is sugar. It's a kind of data contracts here, right? And the core data entities and transformations must live here. And with following dbt best practices, we introduce three dbt layers, models layers, staging, intermediate, and mart. In staging, we clean that data, renaming, casting, parsing complex data structures like JSON, and do not explicitly enumerate all your necessary columns here. It's basically your data contract. And then intermediate level, the most complex one. Here we introduce business logic, and actually core data entities lives here. Then we use them to build our marts. Marts are business-ready entities for ideally for BI and ad hoc analytics. Ideally, what people should query. Let's have a quick overview of how our dbt project works. At this moment, it is self-service, where any data user is able to develop their own models, their own data transformation for their needs. Additionally, most of our users not engineers, so it might be business products analysis and so on. So we prepared a bunch of guardrails. Basically, all guardrails allow us to check is code clean, quality, and secure enough to deploy to production. Considering that almost 80% of our changes, right, generated by AI, I believe guardrails now one of the most crucial part of any self-services. So, first guardrail is the most basic one, dbt compile. As I mentioned before, dbt is a template, right? It's framework. So compile, resolve all Jinja templates. So build an end executable query without running a single query. And it resolves links to the source tables and refs here, like temporary tables like CTA. And even it detects missing models, missing sources, circular dependencies. If dbt compile passed, basically this means that at least your code is ready to run in your engine. At least you don't forget any commas, any brackets, and not missing any sources. As any programming language, we can cover SQL by unit test, especially that cases when some business complex logic introduced. And believe me, some of our analysis, right, they even address dynamic programming challenges using SQL. So unit tests are valuable in this case to test it is still produce what we expect or not. If especially while our end users contribute in the same logic in the same place, several teams and contribute in the same place, right? Unit tests are, I would say, required. So the most important part here, the most valuable part regarding the DBT, you don't have to implement classic unit tests here. You just generate inputs and expected output. That's all. In this case, you just need to provide configuration file. And surprise, surprise, AI tools can easily generate necessary tests. So we have a special cloudy skill. While you're starting working with some complex logic with, let's say, case, when statements, for example, skill always recommend to generate some unit tests in this case. Two more guardrails. Particular end users were trying to work with DBT with like pure SQL, right? So some of them may ignore like source and rep functions. In simple words, they will nail table names. In this case, DBT cannot see that dependency, so lineage now lie to us. It will be crucial while you're deprecating, let's say, some reports and tables. And second one, pre-production environment. Here you can run model against your production data into a production namespace, not production one. So end user will be able to validate on real data, and production tables never touch in this case. So last one, our DBT project is self-service, right? So it means that there are a bunch of teams contribute to this project, and some of them has engineering culture. It might be different than others. Some of them not engineers are also. How do we align them under the same code style? Answer is linter. We use SQL Fluff linter, and we just bring it into our CI/CD, and we just it is just one of step of our CI/CD. If it passed, so your changes go to the next stage. Then finally, when all our CD guardrails are green, your awesome, handsome, clean code have reached production. And I want to be honest with you guys here, because linters here are not green yet, right? It's my personal pain point, because we have a lot of legacy code which we need to where we need to resolve all these violations. We have a special AI agent which refactoring all this code. At this moment, it is still works, so linters not green yet. Another revealing here, unit test, it is even red, because actually unit tests are required only for core basic entities and for analytics engineers only, because it's really hard to push end user, especially not engineers, to implement and to add all these unit tests. Okay, cool. Spoilers. I promised before that awesome, handsome, ideal code must be in production, right? But balance here, we just ready to accept maybe just handsome one. Or maybe next time I will tell you guys how we push our end users, business users to write, implement unit tests in this case. Yeah, what is left over in this case? Immune system, data quality here. System willing to protect us when some bad data introduced in our data platform, or even some organs start failing, right? So DBT, as I mentioned before, DBT provides data sources, And it is basically YAML files where we described our data sources like tables, schemas, tables, columns, and so on, and where we just put our data quality criteria. We have three of them: duplication, fullness, and duplication, fullness, and volume. Volume here, here is row count within expected %, and we have a regular pipelines which just run this data qualities. Now, we're sure that our data clean and quality enough, and we're ready to push into our veins to deliver all these nutritions, vitamins, and energy to our organs. But what is the engine? How we will deliver all these valuable components to our organs? Any guesses? What do we need next? Next organ, what should be? Obviously, heart. Yeah, we need a heart to push all this blood, nutrition, energy to our organs, right? So, yeah, we need our non-complaining 24/7 working machine, right? In our data platform, heart is compute, right? Not only one compute, but a huge cluster. We have many of them, like heart chambers, right? Every chambers, every compute, clusters work with, deal with own type of job, right? We have a SQL warehouse for ad hoc analytics, BI queries, and then we have a shared clusters for Python notebooks, day-to-day work and experiments, and we finally have a job compute for regular production pipelines. It rise up and then goes down. Rise up, executes, and goes down, obviously. And we pay only for the running time. So where heart exists must be vessels. So vessels are pipelines or ETLs, the most clean analogy in our case. Through of them, we deliver all our valuable components, valuable data to our organs. Basically, ETL is runnable task on our engine. And at this moment, we're able to run ETL as ETL, pure SQL, DBT, Pandas, PySpark. An important part, to add ETL, no need to raise a ticket to data engineering team at this moment. It works, again, as a self-service, where any data users are able to design their own pipelines. A few words about how we synchronize ETLs. As a human vessels, like arteries, veins, and vessels, they are connected, right, and synchronized, right? And we have two primitives to synchronize all them. We have custom sensors and triggers. Our custom sensors, we prefer when we expect ready to use data at exact moment. Let's say when we need data at 8 a.m., right? Job rise and check, is it data ready or not? If not ready, we got alerts, error, we got alerts, and no need to, all downstream pipelines stop, so no data processing of half delivered data. Second, triggers. This is a Databricks native tool, and it follows event-based approach. The pipeline starts as soon as upstream data has been delivered, and arrived data just rise event signal. There is no schedule, no waiting, no guess, but you should consider that triggers are limited resource in Databricks. And if I'm not mistaken, there are 1,000 triggers in Databricks. So if you have a hard deadline SLA, you prefer our custom sensors, right? Flowing dependency in the middle of the graph, in this case, take a trigger. And what coordinates all these processes? Orchestration, the nervous system. We use Databricks asset bundles or just DAB, where we just define our jobs with their dependencies, schedule, or alerting. Basically, it's a YAML config files. in our GitHub repo, and again, it's self-service with bunch of CI/CD checks, with one crucial difference here. Every team has its own bundle, right? So deployment is isolated here. As any self-service, there are many contributors to it, right? Our orchestration system, considering that current trend, because basically 80% of our 90% of our changes generated by AI, right? So to make sure that changes broke nothing, we introduce environments, dev environment, basically personal sandbox without any data. Here we can deploy our pipelines to check, is it even deployable or not? Pre-production environment. Here, end users are able to run against production data. As I mentioned before, here we can read production data, but not write. And finally, production. Any pipeline here must run under a technical service principle. As you remember with DBT self-service, right? We a bit kind with some guardrails like unit tests and linters, but here we strict. To reach production, code should successfully pass linters, unit tests, bundle validation, testing pre-production, and here we introduce AI reviewer. Additionally, even that, time to time shit happens, right? And so for those cases, we have alerts with severity, and data engineers have on calls. If pipeline failed with severity P1, data engineers immediately receive phone call and from PagerDuty and start to fixing. Previously, as I mentioned about the food packing system, right? Data management system. So all food packing pipelines are covered by severity P1. So because no food, no gain, no win. Considering that it is self-service, right? We have a special Slack channel for other teams. And they are able to react on their alerts by themselves at this moment. So we built almost full body food. We have a food, gut, blood, heart, vessels, immune system. I believe only one organ left. What is the brain on our analogy? Any guess, guys? Sorry? Same, exactly, same. Actually, brain is literally same. It is you, people who making decision, who take responsibility, who act driven by data, right? But brain needs structured information like dashboards, charts, numbers, facts, experiments, and so on. So when someone asks me what our data platform is, I would say that it is an opportunity to address current and future data challenges. It sounds like too wide, too common, not such a specific. So let me tell in other words. So remember at the beginning, we just bought a Databricks with the end, right? So after what we've learned, let's say, was it Databricks? No, right? That's just step zero. We just buy the instrument, right? What actually works here? What actually works here? Structure, the layers, systems with clear and transparent relations, guardrails with CI/CD, unit tests, data qualities, self-services. When people own their own pipelines, their models, and securely deploy anything they need. And I believe it's data platform, the most important part of any data platform. Then my favorite part, let's see how our data platform works in numbers. This chart is merge requests into our DBT self-service project by the month A year ago, it was around only 60 merge requests a month, right? Now it's around 250 merge requests. For the last 6 months, around 1,400 merge requests have been merged by more than 100 unique contributors, users. If we will rely only on data engineers, right, it's going to be impossible, I guess. It's around maybe 3 or 4 merge requests daily for every single data engineer. So same chart. Oh, sorry. Same chart, but now our pipelines repo. And the left side, year ago, end user contributed into our orchestration system. Everything was a platform team. Then we introduced asset bundles, pre-production, CI/CD checks, right? And after that, about 60 end user merge requests a month. Another chart. Here's a whole picture. The yellow one is a merge request to DBT project. Blue one is our orchestration system. And the green part is our data infrastructure project. And again, it's another self-service with a YAML config files where end users are able to control their access, right? The service principals access or engine configurations. And there are 19 unique regular contributors. So it means that we have at least 19 data platform engineers, right? Moreover, 40 unique contributors in 2 repositories, right? In workflows, I mean, in our orchestration system and into DBT, that means that we have at least 40 data engineers. So 4 engineers cannot do all this, but 50 plus colleagues can, if Rails let them do. And the bottom line here is, bottom line here is a tool doesn't solve your problem, right? Structure, guardrails, and trust do. And we did by Databricks, actually. It was just a first step, not last one. That's all from my side.